Hi, welcome to Key Skill 6 is what I'm trying to say. The team at Master Sophie is filming here in the south of Spain and it is very hot. So if I have some fuzzy hair, now you know why. In Key Skill 6, we're going to be looking at simultaneous equations where they give you some information about the sum of a geometric series and some information about individual terms and how you can put those two pieces of information together, use the substitution method and calculate A and R. So you'll be given two pieces of information. One is about a sum, one is a UN or a specific term, nth term piece of information, and you need to use both of those pieces of information to calculate both A and R. So let's have a look at question 1. The first term in a geometric sequence is 2. Now you should remember that the first term is always A. So in question 1, the first thing I'm going to write down is A is equal to 2. We've been told that the sum to infinity is 3. You need to know your sum to infinity formula. I'm going to write it down for you here. If you don't know that off by heart, you can get your formula booklet and it will be written down there. Now we've been told the sum to infinity is 3. So let's put here 3 in the sum to infinity space and we've got A over 1 minus R. You see you've got two distinct equations and the trick in this key skill is to substitute one into the other. So I'm going to put the 2 here into here. I've also been told that the sum to infinity is 3. So all of that information is now here. I want to take the bottom 1 minus R and multiply it up to the top, like so. Multiply out the bracket, 3 minus 3R equals to 2. And now I'm going to make R the subject, which means R needs to be on a side all along. And these two numbers need to go together. So 2 minus 3. So minus 3R equals to 2 minus 3 is minus 1. R is equal to minus 1 divided by minus 3. R is equal to a third. Because we were given the sum to infinity formula, that tells us that our value of R needs to be between minus 1 and 1. And we have got a third, so that looks correct. If I was in the exam now, I would take a second and put the 1/3 and the 2 back inside this formula here, like so. Sum to infinity is equal to A, I've worked out is 2. 2 minus 1 over 3. And that will give me 2 minus 2/3. Put the 3 on the top. S infinity is going to be 6 over 2, which is 3, which is correct. So always take time at the end of your questions to substitute the numbers back in. I'm not going to do that for question 2 and 3 because I want to wrap this up before I melt. But in the exam, you should definitely take the extra 2 seconds to do that. The sum of the first 3 terms is 35. The second term is 10. Find A and R, where R is bigger than 1. Okay, I'm going to borrow a formula that many of you may not know, but it's super useful. It's the difference of cubes. A lot of people know the x squared minus y squared formula, but not the x cubed minus y cubed. Keep that there for now. We're going to use it later on. Now the sum of the first 3 terms is 35. So S3 is 35. Now we've been told R is greater than 1, so we're going to use the corresponding formula for Sn, where R is greater than 1. Now, the only place that you can put in, because we've been told the sum of the first 3 formulas, we know that n is 3. So that little n here, I'm going to, it's a bit overkill. This n here, I'm going to change to 3. Now, where our formula that we've learned up here becomes useful is you see I've got R cubed minus 1. So R cubed minus 1, and 1 is the same as 1 cubed. So I'm going to have R minus 1, R squared plus R times 1 is 1R, plus 1 squared is 1. So I'm going to use that factorization up here. Just to make it really clear what I've done, I've taken this here, we'll put that for example in orange, and I've used that factorization here to expand that specific part. And the reason why I do that is because then you get this very nice cancelling here and here. So what are we left with from the S3 information? We're left with a times by r squared plus 1r or r plus 1 is equal to 35. Now we can't solve that because we've got one equation and two letters, so we've got to find a and r. You can only have, with one equation, one letter, so it would all need to be r's or all need to be a's. But that is only the first piece of information, so let's put a box around that. And all of that calculation came from, put it in blue so it matches up, the sum of the first three terms is 35. Now we're told the second term is 10. Now they're not talking about sum anymore, they're talking about a specific term only. So they've told us that the second term is 10, so U2 is 10. So when we're talking about sum, we always use S and a specific term only, U. Now the formula for U2 is ARn minus 1 equals 10. And in this case, n is 2. So 2 minus 1 would just be AR1. And generally speaking, you could write that, but a lot of people don't. They would just write AR. Now, that is all of the information regarding the second term. And why that's useful is what you want to do is you always want to make A the subject here. You'll be able to substitute this into your first equation. So in the smaller equation, you make A the subject and then you put A back in here into the bigger one. So now we're here. Let's start a new page. So this A here, we're going to change it into 10 over R. From here, from that second piece of information about the second term. So everything in green is about the second term, and everything in blue is about the sum of the first three terms. Now that divide by r will be much easier if it's on the other side as a times by r. So I'm going to move that up to the right hand side. So it's a times by r. 35 times by r is just 35r. I'm also going to cancel these numbers down. I've got a 10 outside the bracket and a 35. Both of those can be divided by 5 to make my numbers much smaller and easier to manage. So here 2r squared plus 1r plus 1 is equal to 7r. You can see this is tidying up to be a nice, neat quadratic equation. So 2r squared plus 2r plus 2 equals 7r. So I've multiplied out that big trinomial there. And here, to complete my quadratic equation, I'm going to move everything to one side. So I'm going to move that plus 7r to the left-hand side and have it become a minus 7r. These two here are like terms, so they can go together. 2r squared plus 2 minus 7 is minus 5r plus 2 equals 0. So we need to factorize that quadratic. Like always, we're going to use our goggles method, as my student calls it. You multiply these two together. Now, 2 times 2 is 4. So you want a number that multiplies for 4 and adds up for this number here, minus 5. Because we're multiplying for a positive number and adding from minus, the only possibility is both numbers are minus. For example, if you tried minus 2 times minus 2, that would give you plus 4, but minus 2 would be minus 4. So you would eliminate that one. Now, if you try minus 4 times minus 1, minus 4 times minus 1 would be plus 4, minus 4 minus 1 would be minus 5, so that's perfect. So I'm going to split the minus 5r into minus 4r minus 1r plus 2 equals 0. You can see if I do -4 minus 1, I will get back -5r. Factorize the first two together. So let's keep these two here, which factorize to be 2r. That's the most I can take out of both of them. R minus 2. And the other two, I would take out -1. And the reason is I want this bracket and this bracket to be the same. That gives me two brackets. This one being the first, and the one that's repeated, or the one that's the same, being the second. From here, I get two solutions. And I'm going to eliminate this -1/2 one, because I was told in the question that r is bigger than 1. So I've got r is equal to 2. So I've got the r, but I haven't got the a. So I'm going to go all the way back and grab my a formula. And now I've got r, I'm going to substitute that in. A is 10 divided by 2. A is 5. So my final answers are r is 2 and a is 5. Okay, so let's look at question 3 in this key scale. The sum to infinity is s infinity is 8. Now we can write down the formula for that. A over 1 minus r equals 8. And like I said, in the smaller equation, it makes sense to make a the subject. So a is 8, 1 minus r. Everything in blue came from the information, the sum to infinity is 8. The sum of the first two terms, okay, so the sum of the first two terms is equal to 6. Now we know that we need to use the small r formula, this one, because if the sum to infinity exists, then we know that r is between -1 and 1. Now in this situation, we know that it's the sum of the first two terms, so I'm going to have my n as 2. I'm going to open that up using the difference of two squares, so 1 minus r, 1 plus r. Again, because if you can cancel this equation down, like that here and like that there, your life is going to be much, much easier. So I'm left with a, 1 plus r equals to 6. Now I'm going to go back and put in the a that I found in the beginning, this a here, into that equation. So a is 8 bracket 1 minus r. So that's what I've got from here, and then I already had a 1 plus r equals to 6. So everything that's in green, before we move on, came from the second piece of information, which was the sum of the first two terms. And the blue again from the sum to infinity. Okay, so you substitute one into the other, or the second option is you make a the subject for both and let it equal 2. But I think that's probably a little bit harder. So you want to multiply out your brackets. 1 times 1 is 1, plus r minus r squared equals to 6. These will obviously cancel out, and you'll get 8 times 1 minus r squared is equal to 6. So we're going to multiply out that bracket. 8 minus 8r squared equals 6. Make r squared the subject, so you've got 8 minus 6 equals to 8r squared. 8 minus 6 is 2. 2 equals 8r squared. So r squared equals 1 over 4 if we cancel that fraction down. Both of these can be divided by 2. So 8 minus 6 is 2, and you move the multiply by 8 here to the left-hand side, and it's divided by 8. I'm going to take the square root of both sides to find r. Now, the square root of a quarter, you remember from surds, the square root of 1 is 1, the square root of 4 is 2, and I'm going to have a plus minus. So r could be plus or minus a half, All you need to do at that stage is go back to your A equation and get two different values of A, one for each R. So in this situation, A will be 8, 1 minus positive a half, and over here A will be 8, 1 minus a half for the negative a half. So here 8 will be 8 times a half, A will be 4. And here A will be 8 times by, this will be 3 over 2, because you would make that 2 over 2. The double minus would become plus. So it would be, A would be 8 times by 3 over 2. Or 8 over 1 times by 3 over 2. You can cancel here. So that'd be 4, that'd be 1. So 4 times 3 is 12, and 1 times 1 at the bottom is 1. So you get two values of A depending on your two different values of R. I hope you enjoyed that. I hope you're not as hot and sweaty as we are here in the studio. Stay tuned for the next key skill, which is going to be the last one, which is going to be all about worded questions. I know that causes a lot of problems. See you in the next one. Bye for now.